Hello, and welcome to Code Pro, your source for helpful and effective programming tutorials. Today, we are going to be learning about how to create auto layout constraints programmatically. Now, let's take a look at what we're going to build today. I have my simulator open here, and you'll notice that I have a red view centered right in the center of this simulator here. Now, I've already added constraints to it, but I've added the constraints programmatically, not through Interface Builder. Now you'll notice here there's two buttons, Activate Constraints and Deactivate Constraints. So let's rotate the simulator with the constraints active and see what happens. When we rotate it, the constraints keep the view centered right in the center where it should be. Now let's go ahead and deactivate the constraints. Now you'll notice at first glance, nothing seems to happen. Everything seems to look okay. But let's go ahead and rotate our simulator. And now you'll notice the view flies off the screen. So with our constraints deactivated, every time we rotate the device, we get another call to the constraint layout engine, and it notices that, hey, there's no constraints here. What do we do with this view? And then things don't work as expected. Now, if we were to go back into landscape orientation and activate our constraints again, you'll see the view come back front and center, and as we continue to rotate, every call to the layout cycle, our view is right where it should be. So let's go ahead and take a look at how we would build this programmatically. To get started, open up Xcode and create a new iOS single view application. But before we start coding, let's take a look at the two ways we can create constraints programmatically. The first way and the easiest way is to just instantiate instances of NSLayoutConstraint class, configure it as we need it, and then add it directly to the view that we are trying to add constraints for. The second way is using what's called the visual format language, which uses strings to create relationships and returns an array of constraints that we can add to our view. However, this is a little bit confusing, and I'm going to try and go down through the syntax of these strings to try to explain exactly what each part means. So as we look at these strings, you might be thinking, what the heck is this? There's a H and a subview and a 100. What does all of this mean? And to break it down, we really have to apply a set of constraints for a horizontal plane and for a vertical plane. And each part of the string can be explained kind of like this. So the H before the colon represents that this is going to be for a set of horizontal constraints. The vertical line down after the colon represents that this is the super view, that any constraints applied to a subview are going to be with respect to the super view. Now this string right here represents that our subview we are trying to add should be 5 points away from the super view on the horizontal plane. And right below it, we are saying that we want to apply a width of 100 to a subview that we are trying to add a constraint for. So inside of the brackets would be the subview, and this is optional. We don't necessarily have to supply a width, but if we wanted to, we would specify it here inside of the parentheses. And we could easily create this kind of constraint just doing a manual NSLayoutConstraint or a manual width constraint. But the point is, if you understand the visual format language, you can create an entire set of constraints in a string without having to make 4 or 5 manual constraints individually and cut down on your code quite a bit. However, there is a steep curve with this. If you misformat your string, for example, if I forgot to put this dash after my 5, then the application would crash. And Xcode would tell you, hey, we can't parse your visual format string, something's wrong. And for the most part, it's usually pretty good at telling you where the typo is. The same logic applies for the vertical set of constraints. Here we would be specifying that we are on the vertical plane, that we should have a subview that should be height of 100, and that should be exactly 5 points away from the super view on the vertical plane. So that pretty much sums up the visual format language. It's very, very exacting, but at the same time, it's very, very powerful once you understand it. So let's go start coding these out. Now I'm in my viewcontroller.swift file, and the first thing that we want to do is create an array that will hold and keep track of all of our constraints. So what we want to do is just go ahead and create one. Let constraint, or var actually, because we're going to be mutating this, constraint container equals an array NSLayoutConstraint. So now we have an empty constraint container here, and we're going to create two functions. The first one, func create constraints, and a second function that we'll fill out later on, create visual format string constraints. So let's go ahead and create a view to add. Let subview equals UI view. I'm going to just create a new instance of it. I'm going to change the background color. I'm going to set mine to blue. And one more very important thing we cannot forget, we have to set translates auto-resizing mask into constraints equal to false. And more on this in just a second. I'm over on the Apple developer site looking at the property translate auto-resizing mask into constraints, just to kind of explain why we need to turn that off. And you'll notice here that if the property's value is set to true, the system creates a set of constraints that duplicate the behavior specified by the view's auto-resizing mask. This lets you modify the size and location using the frame, the bounds, or the center properties. Note that auto-resizing mask constraints fully specify the view's size and position. You cannot add additional constraints or modify size or position without introducing conflicts. So if you want to use auto layout dynamically to calculate size and position, you must set this property to false, which is what we're going to be doing, adding dynamic auto layout. Another key takeaway here is if you notice, by default, this property is set to true for any programmatically created views, which is exactly what we're going to be doing. If you add them in Interface Builder, they are set to false automatically, which is why we never have any problems with that. So let's go ahead and add our constraints. Okay, so the next thing we need to do is we need to add our subview as a subview to our views subviews. So we'll say view controllers view dot add subview, which is our view that we just created up here, subview. And an important consideration is if you try to add your constraints somewhere up here before adding your view as a subview, you will get a runtime crash. And the reason is the view or the subview must be in the view hierarchy before you can apply constraints. So just remember, always add your view as a subview first, then apply the auto layout. So apply constraints. So I am going to try to apply 4 constraints, a width and a height, a center X, and a center Y. So let's go ahead and start building that out. Let horizontal center equals NSLayoutConstraint. And here we go. So the first thing we need to do for item is define what is the item we're trying to add the constraint to. In our case, subview. The next attribute, NSLayout attribute, we need to say what kind of attribute. So NSLayout attribute dot center X. And now related by NSLayout relation dot equal. And all of these are actually in Interface Builder when you're adding constraints. We're just doing all of this in code now. So what's the item we're trying to, or what's the superview that subview is going to be constrained to? Is view controller's view. So we will specify just self.view or view. And then the same thing applies here. We need to say, again, NSLayout attribute dot center X, a multiplier of 1 and a constant of 0. And I'll explain those in just a second, but so that is our horizontal. Let's now take a look. Let's command click into our NSLayout attribute and take a look at what's inside. So in here you'll notice there's left, there's case right, and case top, bottom, leading, trailing, width, height, center X, center Y, and last baseline. All the different kinds of constraints that we can create. We can do the exact same thing in the visual format language, and obviously the same thing in Interface Builder as well. So we're specifying that, hey, here's our horizontal center X constraint, but there's still 3 more we need to make. So let's go ahead and start with our vertical constraint. I'm just going to try and copy this and just rename it without having to type everything out again. So we'll say vertical center. We'll just change this to center Y equal to view and center Y here. So that takes care of that constraint. Let's also go ahead and do a width and a height. And this is where we will use our constant. So let's just format that appropriately. So now I'm just going to rename these constraints. So we have width constraint, and we'll have a height constraint. And so we need to change some things here. So instead of center Y, this is going to be width related by equal. Now here's where we're going to make a slight difference. Instead of toItem, we're going to pass this nil, and we are going to change this to not an attribute, and we are going to specify a constant of 200 for our 200 width. Now the reason is because a width is a fixed width, it doesn't need to be related to any kind of superview. There should be no relationship. It's just a hard 200. There's no relationship to a superview. There's no other connection, so we specify not an attribute for the second attribute parameter here, and we specify 200 for the constant value here. Now we are going to do the same thing for our height constraint. We are going to change center Y to dot height related by equals to nil, and specify not an attribute for our second attribute parameter, and a constant of 200. Now we need to go ahead and group up these guys. So we're going to do constraint container dot append horizontal center, and I'm just going to copy this 1, 2, 3, format that, change this to vertical center, a width constraint, and finally our height constraint. And the last step is we need to activate these constraints by calling the .activate method and passing in our constraint container. So let's go ahead and build this in the simulator and take a look at it and make sure that everything is working as expected. Our simulator is up and running, and sure enough, our little programmatic view is front and center, 200 by 200, and is responding to rotations like a champ. So it looks like everything's working. Now let's go ahead and start diving into the visual format string. Okay, so to set this up here, let's start out by commenting out our other constraint method, and we will make sure that we are calling our create visual format string constraints. Okay, so we'll just go ahead and copy that little UI view we made up in the other function, and we'll paste it down below here. I'm going to change the color to red, and our translates auto resizing masks to constraints is false. Let's go ahead and add this. And now the fun begins. So the way to create our visual format language constraints is like this. We can call NSLayoutConstraint dot constraints with visual format, and we'll go ahead and start filling that out. Let me just create some spacing here. So the first parameter is the string, which we will specify. The second parameter is options, which we can supply an empty array. The third is a dictionary for metrics, which we'll supply for nil right now. And the second is the views dictionary, which we're going to supply in just a second here. So that's actually the first thing we're going to start with, is we need to tell what views we want to apply the layout to. And the nice thing about the visual format language is you can actually chain together multiple subviews and apply constraints to them all in one go. But we're not going to do that for this tutorial. We're going to try and keep it simple. So let's do this. Let views of type string any equal, and we are going to just do subview with a value of the view we want to constrain, subview. And we are going to pass in this dictionary for the parameter views here. Actually, I'll just call this viewsDict. And let's drop that in here. Okay. So we need to specify our string. Now we have to do this twice. We're going to do it once for the horizontal plane and once for the vertical plane. So starting with the horizontal plane, I am going to say that I would like this view to be 10 points away from the super view that it's inside of. I would like to specify the view in question here is subview, which corresponds to the key we named in our views dictionary. If you didn't use the name subview, just use whatever name that you used for the key. You can change it, but I just like to keep it consistent with whatever the actual view's name. I'll make the key's name match that as well for consistency. And finally, what I want to tell it here is that I would like this view to be, let's just say, 100 wide. And that is all we need to do for our horizontal plane. We need to do the same thing for our vertical plane, however, or we will have a constraint warning for inconsistent constraints, or our auto layout cannot figure out what we are trying to do. And let's do the same thing here, but notice we're going to change horizontal to vertical. So what are we saying now? We are saying that we are dealing on the vertical plane in that we want to apply constraints to our subview, which we specified here in the views dictionary. We want it to be 100 tall, and we want it to be vertically 10 away from the top of the super view specified here. So that's it. That's all we need to specify right now to get this up and running. We still need to put these in the constraint container and activate them, so I'm going to do that now. Constraint container plus equals to, because this is actually going to return back an array of constraints. If you look inside of this function, you'll see that it returns an array of layout constraints. Because really, I'm specifying multiple constraints here. I'm specifying a leading constraint of 10 and a width constraint at the same time in this string. Same thing here. I'm specifying a top constraint and a height of 100. So finally, let's activate this. Set and see what we get. I've got my simulator up and running here, and you can see here is our little red view that we created. 10 pixels from the top, and 10 pixels from the left, and 100 by 100 tall. Let's rotate that around, and we can see our auto layout is still holding true. So everything's working there. At least we have a little message at the bottom there. That's something with the simulator. That's not a layout constraint complaint. Because if you do have broken constraints, the console will let you know and it will tell you that something is broken. So now we're going to do something really crazy here. We're going to use that metrics dictionary that we passed for nil, and we're going to add another subview in relation to the subview that we've already added. So let's do that real quick. I'm going to create another view. And this time I'm actually going to give it a frame, but to prove a point. So I'm just going to say frame cg rect. We'll do 0, 0, 10 by 10 for width and height. I'm going to change this to green so we can see it. And we're going to call this subview 2. I'm going to change that name here and here. Make sure we close off our parentheses here. And we'll add that as a subview to our view controller's view. We also need to add it as a key value pair in our views dictionary. So we'll just go again, sub view 2. Now, let's go ahead and work this into our visual format string. So I am going to construct a string that looks like this. I'll explain it in just a second. We'll go ahead and pass in subview 2. Inside of the super view, and no specified width. Now notice we specified a width for our frame here, but what's going to happen now? And we're going to also add one more constraint here. We'll add a 10 away from the top for subview 2 with still a specified height of 100. So let's go ahead. Now let me just double check my string here. Let's go ahead and run this now and see what it looks like. My simulator is up and running, and you can see that our red view now has its green view right next to it, and you'll notice that it's using up all of the remaining space to get to the end of the super view inside of the layout guidelines. But you might be scratching your head and being like, wait a minute, I specified that it should have a width and a height of 10 and 10, but clearly here it's the same height as the first subview, and its width is much larger than I specified. Well, the reason for that is because when you turn off Translate Auto Resizing Mask into constraints, you are letting the constraints take the wheel. They are going to control the overall width and height regardless of what you specify for the frame. So I could have just done the same thing here and specified as a UI view with no frame, and all of the width and height would be computed by the auto layout that's right here. So the last little part we want to do is actually use that metrics dictionary we were talking about, and we can get some real value from it. So let's go ahead and start implementing that. Let's go ahead and define a let metrics dict of type string any equals a new dictionary. And the first thing we're going to do is add in, let's try this, left padding, NS number with integer literal 10. And what I am going to do now is say that our metrics dict will now become a parameter of this constraint set builder, and I am just going to replace the 10 coded here with left padding. Now let's go. We're going to use this for all of them, so let's go ahead and drop it down here for the nil parameters for metrics dict. Let's go ahead and define one for width. We'll do a width of 100. Make sure we add a comma here, and now we'll paste in width, and we're going to replace that with our 100 here. So that's no longer, so let's also go ahead and do that for that little 5. We're going to call this center, we'll just call it, how about this, spacing. Spacing, NS number, integer literal 5, and now we're going to paste in the key for spacing to replace 5 here. And now we need to do 2 more. Let's do a height. Integer literal of 100, and we will go ahead and replace that here and here. Finally, let's do a top padding. And you can really call these whatever you want. This correlates well with my brain, so I like to use those naming conventions. Top padding here. And then instead of 10 for vertical, we'll just replace that here. And let's go ahead and run that now. Take a quick look. And the real benefit of this is we can now just modify the constants in the dictionary and see that, look, there's been no real changes here. And now we don't have to worry about forgetting to change it in one place in our string, but we left it in another place causing a crash. So let's just say that I want now our top padding to be 50. I want our spacing in between the views to be slightly larger of 15. Let's say the defined width I want for our top view equal to be 75, slightly smaller, and a little bit more on left padding. And just modifying those values right there, now let's see what that impact it has on our actual constraints. So you can see we've already modified all of our layout just by changing a couple values in our metrics dictionary. So it's really powerful, and it's great to be able to just change a few numbers and get the results that we want. So that wraps up a brief introduction of the visual format language. And what's nice is that you can use manual NSLayout constraints together with visual format constraints to mix and match to get the kind of results that you want. However, you have to be careful. It's easy to confuse the layout engine by providing too complicated sets of constraints. So you have to make sure that you keep it as simple as possible so the layout engine knows exactly what to do and there's no unexpected issues. And that wraps up this tutorial covering programmatic auto layout. And as always, you will find the completed project and the source code available for free on GitHub. You can also follow CodePro on Facebook and Twitter. The links are also down below. And if you like this video, please go ahead and smash that like button and subscribe. Subscribe button's down below for more future tutorials to come. Thanks for stopping by.